I'm going to demonstrate the use of Marlowe Lambda in a web browser for a simple contract. Afterwards, I'll discuss a few technical issues around this implementation. Note that this video is not meant to be polished, but instead it's meant to provoke discussion. So what we're going to do is look at a simple swap contract. This is basically the swap of ADA and dollar tokens, but not for ADA and not for dollars, that you find in the Marlowe Playground examples. But we're going to run it in the browser on the chain. We're using the pre-prod network right now. And so this contract involves a party and a counterparty, and they're going to swap tokens. So in this case, the party has 5 Swan tokens they're going to offer, and the counterparty is going to offer 3 Globe tokens. They'll each deposit their tokens, and then the tokens will be paid by the contract to the other party. So basically, they're swapping these tokens. The parties have an address, of course, and here we're doing the signing in the Lambda. This is not really advisable. You should use a SIP30 wallet or something, but for the demonstration, we're just going to deal with the signing in the browser. And then tokens are defined by a currency symbol and a token name. So here we have the currency symbol and the token name. The wallet already has these tokens in it, and it has some ADA to cover transaction fees. Similarly, with the counterparty, they already have the tokens minted and they're sitting in their wallet. And you can see the policy IDs are the same for both of these because I minted them using the same keys, but all these fields are editable, so you could paste in any credentials and any token that those credentials own in either of these and run this demonstration. So what we're going to do first is just create the contract. So what this does is it calls the Amazon Lambda service. To create the contract, we see it's got a contract ID and a transaction ID. The mouse is in the waiting state because we're waiting for confirmation of the transaction. That can take between like 2 and 90 seconds, depending on the block production rate on the network. And so we just have to wait a little bit here. And right now, what the web browser is doing is it's polling the blockchain to see, is there a new contract? Okay, and there's the contract. You can look at all the information about the contract. You know, like for instance, the datum is the contract, the state, and the parameters. So you can browse all of this. This is basically everything that's on the chain. And we're using Marlowe Runtime history service behind the scenes to get all this. But anyway, we have the history there. We're going to, first, the party is going to deposit their tokens. So they're depositing 5 Swan tokens. Once again, we have to wait for confirmation. When the confirmation is done, we will see the next step in the contract. So here was the creation step. This is the second step, and we have a redeemer that is the input from the party of those tokens, the Swan tokens, and there are 5 of them. And you can look at like what the new state of the contract is and all the other information about the transaction. And this is a very simple contract. The counterparty is going to deposit their tokens. Once again, we wait, and that's going to close the contract because the contract is going to pay out the tokens to the 2 parties, and we will see the results of that in just a minute here. It'll be another step in the contract. And then afterwards, we're going to look on the blockchain explorers and kind of see these transactions. So this is taking a little while, but that's the way it is. There we go. So now we see there are 2 steps. The second step is interesting because it has the redeemer, which was the deposit. Once again, we can look at that but it doesn't have script output because the contract is closed, so there's really nothing at the script anymore. Anyway, this is running the contract. We can look at this on Cardano scan. So here's the actual transaction, and you can scrutinize this. You can see that in the creation transaction, we took several UTXOs, consumed those, and then we output to the script address. So this is the script here with the little 0100 symbol, and it received 2 ADA. So we'll take a look at the second transaction. This is more interesting because this is running the actual contract. You see we're consuming the UTXO that's at the Marlowe script. And then now the Marlowe script not only has 2 ADA, but it has the 5 SWAN tokens in it. Finally, we'll look at the closing transaction. And I should also say that there's often a lag in Cardano scan between when the transaction is actually confirmed on the blockchain and when the Cardano scan interface displays it. So if you're very impatient and you click view the contract on Cardano scan, you might get a blank screen. You have to refresh a couple times till Cardano scan knows about it. So anyway, we're consuming this UTXO at the script address, the 2 ADA, the 5 SWAN, and then it's outputting to one party the 3 globes, and to the other party the 5 SWANs. And the minimum ADA that was deposited in the original contract actually goes back to the person who created the contract. So that's basically it for the demo. At some point, we'll split this so it's one page for the party and a different page for the counterparty. And you could actually run the demo on 2 different laptops, one for the party, one for the counterparty. The counterparty will discover when the party has created the contract. We don't have that right now. And basically, what's going on here is we have a AWS Lambda instance running. This is basically a client for Marlowe Runtime. So there's just a thin layer of code there in Haskell that is speaking to a EC2 instance that is actually running all the Marlowe Runtime services. So this is very lightweight, it's ephemeral, it's stateless. You can make the various calls for querying Marlowe contracts, for creating, applying inputs and things like that. And that's basically it there. The runtime is on EC2, and when the Lambda runs, it'll talk to that over socket connections. And then this web page is it's just served from a Google Cloud bucket. So there's actually no server behind this, really. There's no Node.js or any backend stuff. It's just a static web page that has the JavaScript code, the styling, and then the web page you see here. And we're only using 2 libraries. One is to display JSON in this tree-like widget. It's called render.json. And then we're using the AWS SDK. We're making the Lambda calls through that. And we've created some credentials that allow that to happen. So that's basically it. You can see various rough parts. Obviously, the styling is not very clean here. And we don't have a window for error reporting and things like that. But that's where we are.